So what I have over here is a stick, and the stick is going to horizontally strike a ball, and it's going to horizontally strike a ball at distance x above the center of mass of the ball. And so when the stick strikes the ball at distance x above the center of the ball is that's going to cause the ball to rotate. It's going to and what I want to find is I want to find the value of x such that the ball will rotate without slipping when it's struck by the stick. So we want to find the value of x such that the ball will roll without slipping when it's struck by when it's struck by the stick. And let's say that the radius of the ball is given by the variable capital R. And we want to write the value of x in terms of the radius of the ball and in terms of other given constants. So let's say that we strike the ball right through the center like this. Like let's say the stick struck the ball right through the center, shown in the red arrow. If it's struck like this, then the ball will not rotate at all because it will just translate forward if it's struck like that. And the reason why is because since it's struck through the center, there's no torque applied to the ball. And so it'll just translate forward, shown like this in the red arrow. It'll have no rotation, but it will just translate forward if it's struck right through the center like that. But since we're striking the ball a distance away from the center of mass of the ball, that means that the force F is going to apply a torque to the ball, and it's going to cause the ball to rotate. And so we want to find the value of x that satisfies the non-slip condition, meaning we want to find a value of x such that the ball will roll without slipping. So we want to satisfy a non-slip condition. So let's draw a free body diagram of the ball and with all of the forces acting on it. So this is the force F caused by the stick, and we're denoting that force with a capital F. And acting through the center of mass of the ball is the weight force, and it points straight down. And pointing straight away from that weight force is the normal force, and that normal force is due to the ball's contact with the surface of the floor. And also in this problem, we're ignoring any frictional forces. So the coefficient of friction, or the frictional force, is just 0. So the reason why the ball rotates in the clockwise direction is because this force, capital F, or the force due to the stick is producing a force on the ball, but since the force is away from the center of mass of the ball, it's going to generate a torque, or the force of the stick is going to produce a torque, and that torque is going to cause the ball to rotate. And here in the red dot is the center of mass of the ball, or the axis of rotation of the ball, since that red dot is where the ball is rotating, or the axis at which the ball rotates. So the ball is going to rotate due to this force of the stick, since it's a distance away from the axis of rotation of the ball. Now, what about the normal force and the weight force? Do those produce any torque? And the answer is no, those do not produce any torque, because those two forces, the normal force and the weight force, they act right through the center of mass of the ball, and so they don't produce any torque. The center of mass of the ball, or the axis of rotation of the ball, is right at the center of the ball, and since the normal force and the weight force act right through the center of ball, that means they coincide with the axis of rotation, and so they don't produce any torque. The only force that's producing a torque here is this force right here, the force of the stick. So we can ignore any effects due to the normal force and the weight force and just look at the force, or the torque generated by this force F. So if we were to write the sum of the torques that are acting on this object or this ball, we would just write that, remember that a torque is equal to the force that's causing the torque times the distance that the force is from the axis of rotation. So now what's the force F? The force F is just the force due to the stick, and that's multiplied by x. And the value of x is how far away this force act is from the axis of rotation. And the axis of rotation is right there. So the value of x is the distance from the axis of rotation to the force F. And this value right here is equal to the moment of inertia of the ball. And since the ball rotates about its axis of rotation, or about the center of mass of the ball, we can just denote the moment of inertia, or we're finding the moment of inertia of the ball, of a ball about its center of mass. So I'll denote that center of mass with the cm for center of mass, and that's multiplied by the angular acceleration. So this is Newton's second law, but for rotation. What about Newton's second law, or what about a normal Newton's second law for translation? So the sum of the forces is just equal to the mass of the ball, or the mass of the object, times the acceleration of the center of mass. So since we want the ball to roll without slipping, we need to satisfy a non-slip condition. And what the non-slip condition states is that the linear acceleration of the center of mass of the ball is equal to the radius of the object times the angular acceleration. So this right here is the non-slip condition, meaning but all this means is that if we want an object to not slip, or if we want to cause an object to just not slip at all, this is the condition that needs to be satisfied. Meaning the acceleration of the center of mass is going to have to be equal to the radius times the angular acceleration. if we want the object to not slip. So this is the condition that needs to be satisfied. And remember that we're solving for the value of x here. So now let's just substitute in these values. And so let's divide in our Newton's second law over here. Let's divide both sides by m to isolate the acceleration of the center of mass. And now let's solve for the angular acceleration over here. We can divide both sides by the moment of inertia, which is a capital I, and then we now get an isolated value for the angular acceleration. And so now we have a value for our angular acceleration, and we also have a value for our normal linear acceleration. And remember that we said that we wanted to satisfy the non-slip condition. So let's just plug in this value of the acceleration of the center of mass into our equation. So let's just plug in r times the angular acceleration. So we know that the acceleration has to equal r times the angular acceleration. And now since we have r and the angular acceleration, remember back earlier we solved for this angular acceleration expression right here. So let's just plug in this entire expression into this value of the angular acceleration. So if we plug that in, we get the following. And that's if we plugged in the angular acceleration. So all I did was substitute in the values for the angular acceleration. Now let's define what the moment of inertia is for a sphere that rotates about its center of mass. So that equation is equal to 2 fits times the mass of the ball times the radius squared. And usually you can get this on any formula sheet or even on the internet. Now we have a value for our moment of inertia. Now let's just plug in that value of the moment of inertia into this equation right here. So if we plug that in, we just have this. And so since we're dividing r times the force times x divided by the moment of inertia, since we're dividing by a fraction, we can flip this fraction in order to simplify this down further. So if we flip this fraction, we would get this. Because anytime you want to divide by a fraction, you would just flip that fraction. So once we flip that fraction, we get this expression. Now let's cancel out some variables. So we can see that we can divide out a radius or an r, because r divided by r squared will just leave us an r in the denominator. And notice that both sides have a m for mass, and both sides also have the variable for force, which is F. And now let's isolate for the variable x. We can multiply both sides by 2 fifths in order to isolate. Or we can multiply both sides by 2r and then divide by 5. and then we get this value of x. So what does this value of x mean? This value of x just means that if we want the ball to roll without slipping, this is the exact value of x that we have to strike the ball in order to get the ball to roll without slipping. Meaning, if this is so the value of x represents the distance above the center of mass, and meaning the value of x, so the value of x represents a distance above the center of mass, and here's the center of mass of the ball. And the center of mass, or the value of x, is just the distance above this red line that I just drew right here. So the variable x represents how far above this horizontal red line we would have to strike the ball in order to get the ball to roll without slipping. So since the value of x equals 2r divided by 5, that means that we would have to strike the ball at distance 2r divided by 5 higher than the center of mass in order to get the ball to rotate without slipping. So 2r divided by 5 is the final answer. So this is the value that we have to strike the ball at in order to get the ball to roll without slipping.